We now resume our normal not pissing people off in Seattle videos. In terms of expanding the story of the Olympic Wallowa lineament, OWL, or the Klamath Blue Mountain lineament, KBML, we've gotten pretty big. We've expanded from the small surface faults up on the north part of the Olympics to the thrust faults of the Yakima Fold Belt to whatever the heck was going on in the area prior to the Columbia River flood basalts to a multi-state mess. And in the next part of this video, we have to expand to include the entirety of the western part of North America. We start back in Yakima, though. Way back when, in the OWL part of this, we talked about that a lot of the ridges over there are kind of the knuckling result of the area going through a lot of motion. They're the product of progressive thrust faults where they stack up on top of each other. In overall geologic terms, this is a force that comes from something being compressed. If you take both your hands and put them together, notice that to compress them starts to make, I guess you could say, a mini earthquake until one of them slips, to which you've basically just created a thrust fault. But the next phase of our story is the almost opposite. Let me just get this part out of the way first. Land from Oregon down to central Mexico and from California to the Colorado Rocky Mountains is being split apart. Before you go running into the hills saying that the entirety of the West Coast is going to fall into the Pacific Ocean, take a breath. Perhaps what's more scary is the fact that California is coming here to Washington. Something we'll get into next video. This area is referred to as the Basin and Range Province, or for simplicity's sake, TBR. Again, extending from Oregon down to central Mexico and from the Rocky Mountains all the way over to the Sierra Nevadas. And it's very noticeable here in the state of Nevada. General description of this area is also pretty simple too. It's made of basins, or lower area of rocks, and ranges, or mountain ranges. As you can imagine, it takes some massive geologic forces to cause this, and it's very important to our story. But we also have to mention a part of our story that I skipped over previously. The Newberry volcano in Oregon. A curious volcano that's a bit more east than its brethren. Further made weird that it's not a stratovolcano, it's a shield volcano. In case you don't see it, it's right there. Newberry is the product of basaltic rock. It's flowing, it's like Hawaii in a way. Different lava than the Cascades, which is more of an andesite, and it's further east. That's a little weird. Well, we in part have to blame Yellowstone. We discussed a little bit about how the Yellowstone hotspot, upon its first appearance on the North American continent, had pushed the ground up, and in doing so, weakened a lot of the material around here. That gave us a good chance at having the Columbia River flood basalts. And do recall, too, that it wasn't just like one specific spot. There were many dike swarms that occurred in this area that weakened the overall body. Newberry does have the power source coming from the subduction of the Juan de Fuca plate, but it also has easier access to cracked rocks, so on and so forth, from this. And it continues to take advantage of this weaker rock because of the Basin and Range. Hold on though, you said that it was different in the terms of the faults. Well, the Basin and Range isn't some dull brown rock like the Olympics or Silencia or the Crescent basalts or the Columbia River flood basalts either. It's a mass of faults that kind of stack up in the same direction. These basins and ranges are the product of normal faults. Normal faults are almost the reverse of a thrust fault, as where a thrust fault has one block jumping over the top of it, a normal fault has that block dropping. Consider, if you will, that just one drop is, not all that much. But do it progressively and that range becomes higher and those basins become lower. Perhaps what's most fascinating to me is, as with so many things we've talked about so far, they all kind of move the same direction, even when you expand it over the wider area. So what's the deal? Better yet, what's the mechanism? While thrust faults, like what we see in Yakima, are the result of compression, the opposite of that is extension, or stretching. Visualize it with your hands. Pull them apart, and you're stretching what would be in between. Just like OWL and just like KBML, this is a very hot topic. Have this wide of an area and this kind of sequence of faults, there's a lot of thinking that goes into what's the cause. I want to make sure that you know that what I'm going to describe to you in the next video is what makes sense to me. It could be wrong, it's certainly not gospel, it's just in terms of our story that we've been talking about, it fits the bill. I'm glad to do appendix videos of sorts to discuss the other ideas if you'd like. But a few videos ago, I mentioned to you that the Rocky Mountains were at one point in time rising in what's called the Laramide orogeny. I said we didn't have time for it. We still don't have time for it, but it is a part of our story. Annoying sister for scale, but the Rocky Mountains are really weird because they're really far inland, and there's not really an exposed mechanism for how they got so high. But how does that happen? For the Juan de Fuca plate and the overall Pacific plate, there was the Farallon plate. The theory goes that the Farallon plate was subducting underneath the North American plate, but it wasn't subducting at the sharp angle that like what Juan de Fuca does today. It stayed pretty close to the bottom of the North American plate. And it did this until it got to roughly where the Colorado Plateau is today, before it started to dive. What this does is it explains the volcanism that occurred over there. But with that plate sliding underneath of it so far in, it pushes the entire crust up into it. And if you push something this way, it's going to retract back the other way. And when you're contracting back the other way, it's got to be pushing on something else, which just so happens to be KBML. And KBML is pushing into something else we know as owl. Massive spoiler! But in our next video, let's talk about this actual mechanism and this theory that Farallon plate dove underneath of what is Colorado. So in our next video, the oceanic plates strike back. Not so subtle plug. I hope to see you this Saturday for this free presentation I'm putting on at the Black Diamond Historical Society.